Basically, the entire world that we know today is essentially the result of what is known as a supernova explosion. A supernova explosion is an event that occurs in outer space and has to do with the death with massive stars. And when I'm saying massive stars, I mean massive stars. The death of massive stars have a lot more implications than you might think. Understanding supernovas explosions is imperative towards understanding physics and genesis of how our universe got to be the way that it is today. Supernova explosion occurs due to a massive star collapsing in on itself. Shoei Al-Dalal and Walid F. Azam from the International Journal of Astronomy and Astrophysics say in a cumulative study that supernovae are powerful explosions of massive stars that have reached a terminal stage in their evolution. The explosion is produced by a catastrophic collapse of the iron core of a massive star or the collapse of a white dwarf after accruing enough mass from its companion to reach the Chandrasekhar limit. Stars can live and thrive for up to billions of years, but like all living things, its time must come to an end. That is honestly the most basic way that I can put into words what a supernova explosion is. It's just the death of a huge star. Most people might think the death of a huge star might not mean all that much, but it has more implications than just a simple explosion. Let's talk about the science behind a supernova. Astronomers Walter Bade and Fritz Zwicky first observed this unknown phenomenon in the 1930s. But before that, it must be noted that the event of a supernova has been recorded previously in history, like with the Chinese in 185 AD, but the first actionable record occurred with Bade and Zwicky. Continuing to talk about the science behind a supernova, stars form from the gas clouds that we call nebulae, and after gravitational pull attracts enough light elements, mainly hydrogen, and helium, nuclear fusion occurs. Nuclear fusion can be described when atoms undergo enough heat and pressure to release energy. This is what we would call a star. When we would look up in the sky, it's what we see, but that's the process behind it. Again, continue to speak about the science behind a supernova. Stars run on nuclear fuel, so in reality, it means it's going to run out and it's finite. Stars that have accrued enough mass from their nebulae are typically categorized as giant stars. They pass what is known as the Chandrasekhar limit when they use all their fuel up. The Chandrasekhar mass limit is when a star's mass exceeds critical mass and all of its nuclear fuel is used up. It is a concrete number developed by Subramaniam Chandrasekhar in 1976. Continue to speak about the science behind supernova explosions. If the Chandrasekhar mass limit is exceeded, the star then will go through what is known as a supernova explosion. Stars that explode in a supernova leave black holes behind them, and when we don't know much about black holes, we haven't been able to get inside of them because they are entities so dense that not even light can escape their gravitational pull. Continuing to shed light on the science behind the supernova. A huge amount of energy is released when the core collapses to the tiny size of a few kilometers, becoming a black hole, or a neutron star. While most of this energy is emitted in invisible neutrinos, a small fraction of this energy ejects the outer parts of the star, creating an explosion sufficient to produce a supernova. Such a theoretical event is called a core collapse supernova. After the occurrence of the Big Bang, which is generally known in the science world to have been the beginning of what we know as the world, there was an abundance of leftover hydrogen and helium. Where do the other elements that form our universe come from? Our universe is populated with over 100 different elements, and most of them are naturally occurring. Continuing to shed light on the explosion itself. Nucleosynthesis is the process in which atomic nuclei get protons added to them. This happens as a result of a supernova explosion. The ejected matter that we see is actually heavier than the elements that have already been synthesized through a very specific process. Continuing to add information about the explosion itself. Half of the heavier elements that are produced under the process of nucleosynthesis are made by the VP process. The other half are produced through what is known as the R process. Talking about what is known as the VP process. The VP process is the early stage of what is known as nucleosynthesis. This process happens because the initial ejected matter is proton-rich. This allows for a subset of heavier elements to form. It is referred to as the freeze-out because the neutrino levels are too small for more sizable reactions to occur within this process. After what is known as the VP process, the R process now then begins. The R process results in the latter stages of nucleosynthesis and is where the other half of the naturally occurring elements that we get come from. This R process occurs because of a neutron-rich environment and is a series of rapid neutron captures and decays. Talking about the future of supernovas. Scientists and researchers are constantly on the lookout for supernova explosions or stars that may go supernova sometime soon. They do this because they know that when stars dim or their brightness goes down, the age of the star then becomes known. Only massive stars undergo supernova explosions, and Betelgeuse is the largest star that we have ever observed. NASA has recently recorded Betelgeuse to be dimming, and that means that it only has about 100,000 years before it gets to go supernova. Continuing to expand on the future of supernovas. The next supernova visible from Earth will take place in 2037, according to NASA. They obviously could be off by a couple of years, but their calculations are only the beginning of the world of supernova application. Supernovas are not events that typically occur very often and at times can be very rare. We may think that events that occur in outer space may not be able to affect life here on Earth, but that's just not the case. Gamma ray bursts are the brightest events in the entire universe. They happen as a result of a supernova explosion, and they can potentially be deadly. If pointed directly at Earth, which is statistically very low odds to happen, they can wipe out our entire ozone layer. And obviously we know the type of havoc this could wreak on life on Earth because it is already starting to deteriorate. In conclusion, supernovas by definition are the largest event in the entire universe. The energy releases from their mere outer shelling of a collapsed star is unbelievable in scale. It is the reason we have heavier elements than hydrogen and helium, and in many ways it is a groundbreaking process that absolutely is necessary for life to begin its process on Earth and anywhere. We have learned a lot of information regarding physics and our origin through supernovas, and it is only fitting that throughout the course of the future we will only learn more.